Good day, folks. Welcome to Open Source Options. Today, I'm going to show you how you can uh, account and fix areas like this with your stream networks where there should be culverts, but they're not picked up because our surface models, our DEMs, only pick up what's on the surface and can't see the subsurface. So you notice in this stream network, we should have a culvert that has this streamline go through here. We should have one that has it go through here. And if we come to this downstream end here, even at this location, we should have a culvert or a bridge where this goes under and does not come across the road. So we can see a lot of areas in the stream network where we should be able to make some work where the network is not represented properly, and I'm going to show you how we can make some changes to fix that. All right, let's go ahead and get started. Now, the first thing I want to do is I have this DEM. It's called culvert demo. I want to create a copy of this. I'm going to write it to disk so that we can have this to update our elevations to make this all work out properly. So to do that, I'm going to right click on the layer, I'm going to export, I'm going to save as, and I'm going to go save this to a file in this location here, and I'm going to call this culvert demo. I'm going to call it breach because it's going to breach those rows where there will be culverts. So we'll say save, and I'm going to say okay. All right, we have that created. I'm going to turn this hill shape back on. The next thing I need to do is I need to draw some lines to represent where these culverts should be. So to do that, I'm going to go to layer. I'm going to create a temporary scratch layer. There are a couple of important things to do here. So first, I'm going to name this culverts. Geometry is going to be a line string. I need to make sure that my CRS is set to the same as my DEM. These should both be in projected units. So projected CRS, mine's going to be UTM zone 10 north. I don't need to have any fields. I'm going to say okay. Now what I'm going to do is I'm going to draw some lines. I'm going to edit this and draw some lines to connect the upstream end of the road to the downstream end of the road. Select the Add Line feature tool, and I'll come in and I'll add some locations here. Now, an important thing to consider is you want to be able to make sure that your the upstream end of your feature is going to get recognized. So we want to have it touching our current flow lines. I'm going to come down here, I'm going to right click to save that feature. And we'll slide this up so we can see it. And I guess we have a line there. Let's just adjust the symbology so it's easier to see. Let's make this black, and let's give it some nice. Well, this, I don't want the offset. We want the offset to be 0. We want the stroke width to be, we got 1.6 there. Okay. So let's draw some lines for these culverts where we think they should be. Now, there are some data sets that map culverts, and those would be very helpful to you if you want to get this exactly right. Here, I'm just using the hill shade to approximate where I think these culverts would be. And we're not going to get all of them, but we'll try to get some of these major ones to show you how this can make a difference in your stream models or in your stream networks. Okay. Should be one here, it looks like. There should probably even be one over here. There should probably be one over here. And we can see how these drainages appear to come straight down this mountain, but they hit this road and it wraps water somewhere else. Let's leave it at that for now. I want to make one more change down here, and that's going to be where we noticed that at this bridge and culvert we had an issue. So I'm going to come and I'm going to kind of do one like this. Okay. All right. Now let's save these edits and let's stop editing. We haven't done all the locations where we should make changes. We've done enough, we'll be able to see a change when I show you the final result. Okay, so we have this created. Next thing we need to do is we need to buffer these. We need to make these polygons we're going to find the minimum elevation inside of those polygons. Let's come down here and let's find our buffer tool. Let's open that up. And I'm going to buffer the culverts layer by about 2.5 multiples of my cell size. So my cell size for this DEM is 1 by 1 meter. So I'm going to go 2.5 meters for the buffer. And you might want to adjust this based on your specific needs. I found this works pretty well. And then I'm going to run this buffer. I'm going to save it as a temporary layer. It's buffered here. So those are the buffers now. If we turn the culverts off, you can see we have those buffers, those polygon representations of the culverts now. Now I need to find the minimum elevation inside of those buffers. So to do that, we'll use zonal statistics. Open that tool up. The input layer will be the buffered layer. I'm going to pull these from the original DEM. I want to find the minimum elevation inside of that buffer. So I'll change my statistics to represent that. So I'm going to select minimum and only the minimum. And then we'll go back. And now we can calculate this or create this as a temporary layer. So we'll click run. So now we have these zonal statistics there. The next thing I want to do is write that minimum elevation. I want to write that into this copy DEM, my breach DEM. So to do that, I want to rasterize the layer. I'm going to search for rasterize. And I want to overwrite with an attribute. So I'm going to select this tool, vector conversion, rasterize, overwrite with attribute. My input vector layer is zonal statistics. My input raster layer is culvert demo breach. It's going to overwrite this raster, so don't do this to your original. The field to use for burn value is the minimum. That's what I want to have happen. This is going to update the culvert demo breached. So let's go ahead and click run. And this might take just a minute. It's done. Let's close that. Now, we're going to test this out. So I'm going to turn off the hillshade. I'm going to turn off these streams. We're going to pull up our value tool. This is a plugin you can download or install. The value tool lets you see the values of rasters you hover over. So when we hover over these two rasters in the same area, we should have different values. And you can see that we do. You can see that inside this buffer, the values are different, but outside the buffer, they are the same. Okay? Just like that. Okay. Now, what we can do is we can rerun our stream modeling workflow to show what happens here. So let's do that. So let's go to the processing toolbox. You'll need to have the R tools installed here. And I have a video, my QGIS installation video shows how to do that. Hopefully you've been through using these tools in my previous tutorials so you know what to do. The first thing we want to do is we want to fill our breach DEM. We're going to use r.fill.vir and we're going to use culvert demo breached, and we're going to leave the defaults, and we're just going to save this to a temporary file. Actually, we'll save this to a file just to make sure everything's good. So this will be build culverts is what we'll call it. Save, and we'll click run, and we'll let this tool complete. Okay, that tool has completed running. Let's close this. Now that it's filled, we need to calculate the flow accumulation, which we can do with the R watershed tool. So we have our watershed here. We're going to input our elevation as filled culverts. We're going to set the minimum size of exterior watershed at 500. This is something you might need to change a little bit depending on your watershed. 500 works for this one. I'm going to enable single flow direction. and I'm going to use positive flow accumulation even for likely underestimates. This will just make sure we have smooth lines. And then the only one I want to save is the number of cells that drain through each cell. So I'm going to skip these other outputs. There are a lot of them for this tool. This will just keep our workspace clean. Okay, and then I want to save this to file. And I'm going to call this flow accumulation culverts. So we'll save that, and let's click run. And this will take just a minute to run, so I'll pause and come back. Okay, that's completed. We'll close this. So now we can take a look at this flow accumulation just to see what it looks like. And you can see we have this accumulation, and it looks like a lot of these are running through the areas we've reached. So let's just go and make sure we're all set, and we can calculate the streamlines now. I'm going to just load that up with r.stream.extract right here. So we'll open this up. Our input elevation is going to be filled culverts. Our input map, accumulation map, is going to be flow accumulation culverts. I'm going to set the minimum at 20,000. I believe that's what I used for the initial stream network. And I'm going to delete stream segments shorter than 100 cells, just to kind of prune this and keep it clean. I need to set the OGR output type to line, and then we'll come down, and the only thing we want to save here is the unique stream IDs vector. We'll save it to a file, and we'll call this streams with culverts. We'll click save. I'm going to skip this output and skip this output, and I'll click run. And this again will take just a minute to run, so I'll pause. Okay, that's completed. Now we can close and we can take a look at the differences here. So I'm going to take the streams with culverts and put it up on top of the other streams layer. I'm going to turn off the flow accumulation so we just have the hill shade. I'll also turn off the buffers and the zonal statistics. Okay, now let's grab the streams with culverts. Actually, I'm going to keep the culverts on so we can see where we should expect some changes. Let me change the layer styling here. From a simple line, let's change this to a dark blue so it's more easy to see. And then we'll even increase the stroke a little bit. Okay. So now we can see our original stream layer without culverts and the streams where we've added the culverts. Okay. And you can see here where we've added these culverts, we now have these streamlines coming through. And you see not coming right where those culverts are, and that's because that minimum elevation we selected and filling those in may have changed things just a little bit. You can see how with adding these culverts, we're now getting these streams to come downhill. You can see that you even forced the stream back under the road and into a different flow path than it was originally coming from. And you can see, it's strange how, sometimes this can change other things elsewhere. You can see how this has changed here, which is a little strange, but some of these other ones haven't changed. And so you can see how we're able to insert these culverts in and change the DEM to force some of the flow network characteristics that we expect to see, even if our DEM does not represent. I hope you found this useful. Don't forget to check out open source options, where I have some free courses coming online. The first course is going to be an introduction to GIS, geospatial data, and the like. So if you know anyone who wants to get into GIS, it's going to be a great starting point for them. I appreciate you watching. I appreciate your support. And please leave a comment if you have ideas for future videos, or if there's something you saw that I did wrong here.